Hello, let's try to solve Leetcode problem 3152, Spencer array 2. So for this problem, basically there are two ways to solve it. So we are having an array nums, so this is going to be a random array, and we are also having a query, and we want to answer each of the queries. So the return going to be an array of Boolean value answer. It can be true or false, so such that the answer I is true if the nums from I to I, so that is both included inside of the query. So for example, for this first query, it's going to be 0 to 4. It means this is 0, 1, 2, 3, 4. So we just want to check this subarray if it is true or false. So what is true or what is false? It is determined by the parity. Yeah, so if every pair of its adjacent elements contains two numbers with different parity, so this is going to be true. So for example, 3, 4, 4, 1, 1, 2, it is the different parity because 1 odd, 1 even. And for this one, it's 2 even, so this is why it is false. Basically, there are two ways to solve the problem. The first way is going to be the binary search and going to be n log n time. But for this time, I'm going to use the O(n) time to solve it. Let's first try to check the binary search idea. Maybe this is easier to think about it. Yeah. So for the binary search idea is we just list all the group if it is even odd, even odd. So for example, 3, 4, 1, 2. So this meets the condition because it is odd, even, odd, even. So it meets the condition. So we're gonna put the index inside. It means from 0 to 3. So this is one group. And for another group, 4 and 4. This means this is 6 and 6 are another group. And then we're going to use a binary search to check each of the queries. Yeah, so for example, for the first query, it is 0 to 4. Because this is 0, 4 is not inside each one of the group. If it is inside, so we're going to return true. And we can say this 0, 4, it is not inside each of the group, so it's going to be false. So this is why we can use a binary search to find it. So for example, we're going to use a binary search to search the first index with this 0. While we are searching the 0, we're going to use a bisect right, and we find the index with 1. For here, and because we use the bisect right, this is the index 1, so one position before it should be here. So this means it is from the index 0. Then we're going to check this number 4 and 3 because 4 is more than 3, so it's going to be false. If this number is less than or equal to this 3, so definitely it's going to be true for this query. So this is the n log n time. Now let's try to use a better way to solve this problem. So currently we have this nums array. Let me copy it here. The second way is that we're going to put all those numbers inside of the pairs. So we're going to pairwise all those numbers. Because if we pairwise the numbers, we just check a pair of each of the elements. So definitely we're going to pair each of the numbers. We're going to check if it is even, odd, or odd, even. So if it meets the conditions, we're going to do some operations to it. So first of all, let's just pairwise all of them. So 3, 4. So for the next, it's going to be 4, 1. And the next, it's going to be 1, 2. And the last pair, it's going to be 2, 6. So if 3 and 4 meet the different parity of a group, of a pair, and 4 and 1 also meet the different parity. So definitely 3, 4, 1, it meets the different parity. So this is the property. So if 3, 4 meet the condition, 4, 1 meets the condition, 1, 2 meets the condition, definitely 3 to this number 2 meets the condition. And for this 2 and 6, it didn't meet the condition because both of the numbers are even. Yeah. So from this way, we can solve the problem easily, and we can use the prefix sum to solve it. So inside the pairs, if they have the different parity, so we're gonna set it to be 0. 0 for the second one, third one, and for the last one, if it didn't meet the different parity of the two numbers, so we're going to set it as 1. Now we want to use the prefix sum to solve the problem. Yeah. So for the prefix sum, we're going to prepare parity as 0. Then we're going to prepare all other values. We just copy and paste it here. Now we have the prefix sum array, and we can answer the queries directly. So if it is 0 to 4, so this means because currently on this kind of number 0 or 1, it means it is a pair. So for this number, so for the queries 0 to 4, so for the index 4, actually it is just this number. It is not 4 plus 1. It is just this number. It is 1. And for the query 0, so we can also use the index 0 directly. Yeah, because this is not the normal prefix sum, because each of the index is going to represent a pair of values. Yeah. So for queries 0 to 4, we can use the prefix sum of 4 minus prefix sum of 0. Yeah, because basically this 0 to 1, it is the whole array. Yeah. So if the prefix sum equals to 1, it is not 0, so we're going to return a false. So if it is 0, definitely it is true. So for example, if the query is 0 to 3, basically it means these 3 zeros. So we're going to use the prefix sum 3, it is 0. Prefix 0, it is also 0. So the result is going to be 0. So if it is 0 to 3, definitely it's going to be true. Now let's try to solve it. So we're going to, first of all, we're going to prepare a prefix sum. Let me prepare an empty array. So I'm going to prepare two numbers in pairwise the nums. I want to check the numbers. So if a plus b modular 2 equal to 0. So if the sum of them equal to 0, definitely this means it is not a parity. It may be two even numbers or it may be two odd numbers. Yeah. So if it is not different parity of the two numbers, so this means we want to put the prefix array inside a value as let me think. We're gonna put it as 1. Otherwise, if it is equal to 1, a plus b modular 2 equal to 1, it means it is even odd. So if it is even odd, so we're gonna put it 0 inside. Now we want to prepare the prefix sum. It's gonna be the list accumulate with the prefix and initial gonna be 0. So let's import the accumulate. So from iter tools, we're gonna import the accumulate because we're gonna use this accumulate method to just accumulate. It's basically like a prefix sum with a padding of 0. Now we can answer the queries. So basically the answer is gonna be pre-b minus the prefix a. So for AB in queries, yeah, so this is going to be the answer. Now let me just run it. There's something wrong. Yeah, I got an answer to 1. It should be true or false. Yeah, so this value, the prefix sum b minus the prefix sum of a, it should be 0. If it is equal to 0, it's going to be true. Otherwise, it's going to be false. Now, as you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed and it's pretty fast. And I think this is the best method to solve the problem because this is just a O(n) times complexity and the coding is much easier. So if we use the binary search, definitely there's a lot of coding. First of all, we're going to list them inside a group. So you have to be familiar with how to list the even odd inside each of the group. As you can see, there's a lot of checking, and we have to check and put it inside. And then the second one, we want to check each of the queries, and we're going to use the binary search to check if it meets the conditions or not. If it meets the condition, we're going to return true. Otherwise, it's going to be false. As you can see, the binary search actually is a lot of coding, and it's also easy to make mistakes. Yeah. And for this O(n) time prefix sum, it's difficult to think about it, but the coding is much easier. Yeah, so that is the difference of the two methods. Thank you for watching. See you next time.